Thank you for attending our Indiana-Michigan Power webinar, Transportation 2019 Electric Vehicles Charge Ahead. My name is Sierra Conley, and I am the host of today's webinar. We will be sending everyone a follow-up email within the next couple of days that will include a PDF of the PowerPoint presentation and the playback link to the recording of today's webinar. Before we begin, we wanted to cover a few housekeeping items. At the bottom of your screen are multiple application widgets you can use. All of the widgets are resizable and movable. If you have questions during the webcast, you can submit them through the Q&A widget. We will try to answer these during the webcast, but if a fuller answer is needed or we run out of time, it will be answered later via email. Some networks cause slides to advance more slowly than others, so logging off of your VPN is recommended. If your slides are behind, pushing F5 on your keyboard will refresh the page. You can find additional answers to some common technical issues located in the Webinar Tips and Help widget at the bottom of your screen. We will be conducting polls during the presentation and would appreciate your participation. I'll open our first poll now. Please be aware that you are not the only participant today. The names of other attendees are not being shown to you for privacy. I'll now introduce today's presenters. Mike Carter is a senior engineer for the Questline service. Mike has a BS in engineering and an MBA degree from The Ohio State University. He has worked with various EPRI centers supporting electro-technology applications and spent 10 years conducting due diligence for technology commercialization. At the Questline service, Mike writes articles for the newsletter, answers Ask an Expert inquiries, and develops webinars on energy topics. Jason Whitman is a Senior Energy Efficiency Program Coordinator for Indiana-Michigan Power's commercial and industrial customers in Michigan and has been in this role since May of 2016. He has a BS in Computer Information Systems from Colorado Christian University. Prior to joining the energy efficiency team, Jason worked at Indiana and Michigan Coke's nuclear power plant for 5 years as an instrumentation and controls maintenance planner, and for 13 years in the U.S. Air Force serving as a nuclear weapons launch officer and data and technology acquisition officer. I'll now go ahead and turn it over to Mike, who will get things started for us today.
Well, thank you, Sierra, and welcome everyone to our July webinar on the subject of electric vehicles. We've covered a couple other topics this year in a series of 4 total webinars that the Indiana-Michigan Power is offering you this summer. We've touched on building automation systems. We've touched on chiller and rooftop unit maintenance, and you can find playback links to these on our website at www.electricideas.com. Just click on the Smart at Work link at the top, and it'll take you to a page that has a pane that will get you to all the webinars. And of course, today's topic, electric vehicles, will be on there in a few weeks, and we have another webinar coming in August on EPA's Portfolio Manager, tracking and rating tool. It's going to be very valuable for you. But today we're talking about electric vehicles, and a gentleman known as Elon Musk, maybe you've heard his name, a couple years ago made a prediction, and he says at a governor's conference, he said, I think things are going to grow exponentially. There's a big difference between 5 and 10 years. My guess is probably in 10 years, more than half of new vehicle production is electric in the United States. Not too long ago, J.P. Morgan predicted that by 2025, which is 6 years from now, electric vehicles and hybrid electric vehicles will account for an estimated 30% of all global vehicle sales. And more recently, Morgan Stanley projected that electric vehicle sales will surpass gas-powered cars by 2040, which is 21 years from now. Another consulting company, Bloomberg, also predicts that by 2040, 57% of all passenger vehicle sales and over 30% of the global passenger vehicle fleet will be electric. Now, we don't know which prediction is more accurate, but we do believe that electric vehicles are here to stay. This webinar today, we're going to explore the different types of EVs. We're talking about battery storage technologies and vehicle charging stations, We'll compare the fuel costs and emissions of EVs to traditional internal combustion engine vehicles, and we'll also examine the impact that EVs have on the power grid, what financial incentives might be available, what's the market availability of EVs, and what are some of the barriers still to their commercial success. We'll also answer any questions you might have. Just type those in the Q&A text box, and we'll hit those at the end of the presentation today. One of the main goals of EVs, or at least originally, was to replace petroleum, our dependency on petroleum. And then reducing the cost of operation really was more of an extra benefit. And of course, you can see here from the data, the U.S. has a lot of its energy consumption represented by liquid fuels. And in fact, the transportation sector alone uses about 1/4 of total U.S. energy that's consumed. You might also be surprised to hear that electric vehicles aren't really new. Back at the turn of the century in 1897, the first commercial EV application was New York taxis. You can see a picture of those lined up here. Again, in 1900, of all the cars that were produced in the U.S., there were only about 4,200 cars, but 1/4 of those were electric. And as you can see here, the 1902 Phaeton had a range of 18 miles, top speed of 14 miles per hour, and cost $2,000 back then. Well, that's the equivalent of about $60,000 today. Now, why did electric vehicles more or less disappear back then? Well, partly because of the discovery of crude oil here domestically. And then a very inventive gentleman, Charles Kettering, figured out how to better start internal combustion engine vehicles with an electric starter. My grandfather had a tractor that had to crank start, and I'll tell you, it was very dangerous. You can pretty easily break an arm with that kind of a situation. And of course, Henry Ford figured out how to mass produce vehicles with internal combustion engines as well, and put a dent into the electric vehicle trend. In terms of vehicle types, there's various types of vehicles powered by electricity. One we're most probably familiar with today, the most popular, is the battery electric vehicle, BEV. Basically, it's an electric vehicle that runs exclusively on electricity via onboard batteries that are charged by plugging into an outlet or a charging station. And you can see here, you're talking about 20 to 90 kilowatt hours capacity. And here's some examples of makes and models that represent BEVs. We'll look at a more substantial list here in just a little bit. If you look under the hood, so to speak, things are quite different. In a BEV, the internal combustion engine, the transmission, and fuel tank, they're all replaced by a battery pack, electric motors, no more oil changes. And you see here that you basically take AC power, rectify it to DC, charge the battery, and then that power energy from the battery is pulled out in DC form, inverted to AC, and it runs. And actually, an AC motor. You would have thought it would be a DC motor, but it's an AC. A few more words on that here in a second as well. So that's the battery electric vehicle. There's hybrid electric vehicles as well. And there's both a parallel design and a series design. So here is the parallel design shown here. If you look at the pictures, maybe it makes a little more sense. In a parallel design, either drive source operates independently or both together. So you can move the car by just running the internal combustion engine. You can move the car by running just the battery electric motor, or you can run both at the same time. The battery pack in a hybrid electric vehicle is only charged by the internal combustion engine. And so, or if you use a larger battery pack and you add a plug, that allows the battery to be charged in the electric grid. And again, you can see here the makes and models of some of the hybrid electric vehicles in the parallel series. In the series design, you can see here the internal combustion engine, all it does is charge the battery, and only the electric motor turns the wheel. So it's a little bit different there. And we're talking about a lot less energy capacity, 12 to 18 kilowatt hour, at least for the series type, and really half of that for the parallel type we just talked about. And the Mitsubishi Outlander, Honda Clarity are examples of this particular type. Of course, all that depends upon the battery technology, and the main battery for battery electric vehicles is lithium ion. The main battery for hybrids is nickel metal hydride. And as we look at the lithium ion type batteries, some people have said, well, you know, we're really trading our oil dependency for lithium dependency, and there's some truth to that. Although the U.S. is home to 6 of the world's largest lithium deposits, and the world's 32 largest deposits contain enough lithium to power the EV industry through at least the year 2100. In fact, the Kings Mountain Belt deposit in North Carolina, which hasn't operated since 1991, is actually the 3rd largest in the world. Of course, lithium batteries have a reputation as having a tendency to overheat as well. A little concerned about that. More of a concern in lithium batteries like laptops. Ones for vehicles are really a lot different, and we rarely see that kind of a problem. If you look at the table here, it shows you why we like lithium ion. If you look at the far right, we have the different batteries: lead acid, NiCad, nickel metal hydride, lithium ion. If you look at the specific energy, how many kilowatt hours you get for kilogram of weight, you see you get a whole lot more, 4 times as much energy stored in the same amount of weight in a lithium battery than a lead acid, and not quite as big an advantage over the other two, but still a pretty big advantage. There's been a lot of development in battery technologies. You have, if you look at the vehicle, you're looking at 60 to 175 kilowatts of power under the hood. It's a higher voltage, 200 to 400 volts. That's a concern for some first responders if they have accidents, etc. You get about 3 to 5 miles per kilowatt hour of energy stored in the battery, and the cost has come down considerably in the last 10 years. The latest number is about $270 per kilowatt hour. And again, if you have 100 kilowatt hour, you can see that's $27,000 just in the battery alone. Again, you might not know that these lithium batteries require active cooling and heating, cooling in the summer and heating in the winter. And of course, that reduces the range when you have to do that. I mentioned that the motor technology is not DC motors, it's actually AC motors. And the reason for that is you have higher RPM, it enables regenerative braking, you have a continuous power, a wide range of continuous power. AC motors spin from 0 to about 13,000 RPM without needing to change gears.